Hi, now I'm going to explain you about the next experiment, that is nothing but UART. UART stands for Universal Asynchronous Receiver Transmitter. This one is used for serial communication. So here we are using 8-bit Universal Asynchronous Receiver Transmitter. So this will be supported with RS-232 cable. This is nothing but the serial data transmission between DTE to DC. So DTE is nothing but data terminal equipment, data communication equipment. So the data transfer between these two devices, data terminal to data communication equipment, using some protocol, that's something called RS-232 cable. So here internally this will be having UART port. So now I'm going to explain you how UART is working in PSOC and everything. So now this is a block diagram of UART, Universal Asynchronous and Receiver Transmitter. So this is a block diagram for UART. So already we knows that PSOC having internal UART, and UART is the combination of TX and RX. So separately we will be having both TX and RX in our user modules, but combination of these two UART is also available for you. So directly we can take UART, otherwise separately we can take TX or RX. Okay, that is your choice. So now I am taking directly UART module, that is nothing but combination TX and RX. So this is a block diagram for UART. So here in this block diagram, this will be consisting buffer, shift register and control register. So do you know the functionality of serial communication? That data transmit from start and data and stop bits are there. So that is nothing but data start and parity bit is there and stop bit is there. Okay, so for that purpose what we have to do is, so initially we are selecting some UART module in our user module parameters. So I am going to explain you how to select this UART module in user module parameters, and we need to do the some frequency calculations in this UART port. So for that purpose what we have to do is, so in this experiment we are selecting some user modules, something called UART. So only I am selecting UART. Okay, one UART. So this should be available in your user module parameters, user modules. So there we can select UART directly. So how to means, simply select, goes to digital communications, and here you can see like different types of digital modules. So in that we are going to select, otherwise you can select TX RX, but directly I am taking UART module. Okay, so now I am selecting UART. Okay, after selecting the module, go for interconnect view and place the module. So this should be occupying two blocks, two 8-bit module blocks, like one is a receiver and another one is transmitter. So this should be interconnect view. In this interconnect view what we have to do is, so we need to connect the port pins. So in our PSOC microcontroller there will be internally connected with 2.7. This port is internally connected with the transmitter, and 1.6 this should be internally connected with the receiver. Simply we need to place the jumpers at the UART2 port. So then internally these two port pins are connected with these two transmitter and receivers. Okay, now here very important thing is, so here we need to set the global resources. So generally our PSOC worked on PSOC. So before going to that, we should know what is baud rate and everything. So here in serial communication, baud rate is taking most major place. So in that what we have to do is, so in order to set the baud rate 9600 bits per second. So baud rate is nothing but number of bits transmit per second. So here we will be taking 9600 bits per second. So so generally our PSOC microcontroller, 8-bit microcontroller, then 9600 into 8, that is nothing but 76800. Okay, so since clock frequency it should be set to 8 times required baud rate, so that is nothing but 76,800. so how this came means 9,600 into 8, then we will be getting some 76,800 frequency. So this much of frequency we need to set the clock frequency, then only we can send the data as well as receive the data. So using this frequency dividers, we can set maximum up to 76,800 clock frequency. So now for that purpose what we have to do is, so in our global resources we will be having 3 volt frequency divisions like VC1, VC2 and VC3. so in VC1 what we have to do is, VC1 formula for VC1 is system clock by n. So system clock is nothing but 24 PSOC worked on 24 megahertz, so 24 megahertz by 2. So here I am taking, for example, I am taking voltage divider. This is a n, something called voltage divider. So this I am taking maximum value is 1 to 16, so I am taking 2. Then I will be getting some 12 megahertz frequency. Again go for VC3 source. So VC3 is divided into source and divider. So source I am taking VC1 output, and divider I will be taking maximum divider is 256, so in that I am taking 156. Okay, so VC1 by n, so 12 megahertz by 166. Then finally we will be having 76,923. so this is approximately equals to 76,800. so now this will be approximately equal, then we can send the data as well as receiving the data. Now we need to synchronize these two frequencies for system clock as well as our microcontroller clock. So that's why we need to do this frequency divisions. So here I am taking 156. so this is one option. So based on your calculations, for example, one more calculation is also there, 156, otherwise 3 8 13, like this. 3 means VC1 equals to 3 dividing with 3, VC2 that should be divided with 8, and VC3 should be divided with 13. So then also we will be getting some 76,900 something. So that is also approximately equals to 76,800. So this is the calculation, frequency calculation for baud rate set for this PSOC microcontroller. So now finally these values are fixed in our global resources. Now what we have to do is, there I am doing some calculations now. So here VC1 equals to system clock by n, so 24 by 2. I am getting some what value? I am getting something 12 megahertz. Again I am dividing with 1, so again 12 megahertz. So VC3, this should be classified into source and divider. So source I am taking directly VC1 and divider with 156. So finally we will be getting 76,800 value. Okay, so now this is the global resources for UART module, and now we need to set the user module parameters for this one. So what we have to do is simply clock frequency. So finally we will be having frequency from VC3 now, then we need to set the clock frequency VC3. Again go for RX input. So this is a receiver input, and TX output is nothing but transmitter output. So in interconnectivity what we have to do is, so here we need to fix some port pins. So this is a transmitter and this one is a receiver. So I am connecting transmitter to row 0 input 2. So this is also your choice, you can make the changes. Okay, so I am selecting row 0 input 2. Why? Because port 2.7 is internally connected with our PSOC microcontroller. That's why I am selecting row 0 input 2. For example, you need to change some modification, then change the port pin. So you need to change this one. Okay, so here you need to select concerned output and select the port pin. Now I am selecting port 2.7 for transmitter, and coming to transmitter, so this one is a receiver. So receiver part is over, 1.6. I am connecting 1.6 for receiver, and transmitter I am connecting row 0 output 3. For this one is connected to port 2.7. Okay, so now after that what we have to do is, simply we are set the all user module parameters. So buffer size is 8 bit now, so 8, and here this is your choice, no need to fix same much. So here give some parameters, so 13, 32, 32, 32 bit, 32 bit, and disable none. Remaining options are gives none. Okay, so now after interconnect view, after getting the interconnect view, go for generate the application, and after that go for application editor to write a code. Now I am going to write a code for UART module. Okay, so now so in this code what we have to do is, so this is a complete program for UART module. So in this program what we have to do is, the logic for this one is simply I am transmitting some data and receiving some data, okay, through UART ports. Okay, so how it does means we can see here. So now in this generally our execution starts from main only. So main function. So here these are the header files. So first one for m8c.h is, this is nothing but 8-bit microcontroller, and API definitions for all user modules, PSOC API application, that is nothing but programmable application programmable interface. And here one more header file is UART header file is directly I am taking. Okay, now coming to main function, here what we have to do is simply we are taking user UART module, then we need to start user UART module. So UART1 start with the parity none option. So UART having UART or TX or X, these will be having three parities. Parity none is there, parity odd parity is there, even parity is there. So in that we need to select none parity. Okay, so now go for next. So come down here, while one. So here we will be taking infinite loop. Okay, so why? Because it will be searching continuously where data is receiving or not. So if there any case receiving some data, immediately that should be transmitted to PC. Okay, that's why we have to get we need to give in infinite loop. So in that loop what we have to do is, so UART send data. Okay, so UART send data something CHI. So I am taking some array function. Okay, so CHI. So here I am getting some data, then immediately this should be transmitted to PC. Okay, and put clear flag, and again ch1 of I array, something variable. This is a variable, something variable called ch1 of I of array. So this one UART get. So this is a command for, this is very important command. So this one is the command for receiving the data. Okay, so for example through keypad I am giving some data, so that should be receiving through this command UART1 c get character. So again this data stored in this ch1 of array. Okay, so for example I am given a, that should be stored in this variable ch1 of I of array. Okay, again go for ch1 I plus 1. Okay, so continuously we need to increase the so continuously it is getting. So after some delay, so UART1 put string ch. Okay, so now we need to transmit the data. This is a command for transmit the data. Okay, so put string ch. So ch, what is ch is nothing but, so ch I am getting some data. Okay, here so ch, so I am mentioned here like a unistring. Okay, so this should be transmitted to PC. So this is a command for transmit the data. Okay, and now again go for this is a enter mode. Again go for space, put clear flag, and some delay. After some delay, given 1 second delay, and UART1 c put string welcome to my UART. So this is a string. So this is your choice. For example here I am giving some string, something called welcome to UART. So this should be transmitted to PC. Okay, so after some space again go for put string ch1. So now here what we have to do is, so ch1. So ch1 is nothing but continuously I am getting some data. Okay, that should be transmitted. So this is a receiver data. So receiver data I am getting, for example I am given some input data. So that should be transmitted to PC. Again go for put clear flag and some delay and I plus plus. Okay, so I plus plus is nothing but ch1, continuously it is getting some data now. So I plus plus and continuously it will be sending the data. So transmitted data is welcome to UART, unistring transmitted data, and the receiver data is welcome to my UART. So this is the receiver data. Okay, so any button, you can press any button, immediately this should be transmitting, receiving like welcome to my UART. Okay, so now this is a delay function. For once, and we are mentioned a delay 1 second, 1 second, 2 seconds. So this is a delay function. Okay, so this is a code for UART. Okay, so now after writing a code, go for build processor, build F7. Okay, after getting 0 errors, go for Cypress C symbol and dump entire code into our microcontroller and simply reset the button. Then I'm going to explain you hardware realization. So in that procedure, what we have to do is simply we are connect that UART port, that is nothing but PC to our microcontroller. So always connect UART to and there we need to place one jumper for internally connected with port 2.7 and 1.6. so then after connecting the jumper, just reset the button, then we can see the output like unistring. Again we need to give some input data, like press any one key, then we can see welcome to my UART. Okay, like this. Okay, so in that terminal what we have to do is, so that terminal software in PC means we have to see some terminals, something called hyper terminal software is there. So in the terminal we need to set 9600 baud rate. Okay, select consider COM port and reset the button, then we can see the output. Thank you.